All right, so Mac 248, Thursday. What did we learn today? Well, I went through pages 165 through about 204 in the book. We are in the stage, the milestone in this course where we have to really get a handle on what bottlenecks and constraints and non-bottleneck resources really are in the context of this plant, and so that we can understand and maybe use them for any other situation that we find ourselves in life. But for this, we really need to understand it in terms of this plant. So I just kind of picked up where I left off describing that a bottleneck, follow me over here, a bottleneck is any resource in the plant whose output is equal to or less than the demand placed on it. A non-bottleneck resource, NB here, has greater capacity than the demand placed on it. This ended up to mean was we have to focus like a laser on this one because it's controlling throughput and our ability to make money. But this one here, we may want to restrain it. We may not want to produce more than we have to on the non-bottleneck resource because it may end up causing a disruption in the flow of work through the plant to its final assembly and then shipping to our customers. Because that's what we want. We want our products to get through the plant as fast as possible into our customer's hand when they expect it so that they can pay us immediately, and then our throughput rate goes up. Okay, so that's what a bottleneck and a non-bottleneck are. I wanted to say that a constraint, to think of that word in this context, a constraint is something that might either mean that we need to restrain something, or we need to find a way to relieve what it's doing to us. So a bottleneck is a very particular kind of constraint that we want to relieve or offload somehow. A non-bottleneck is a constraint that we may want to hold back and keep from overproducing because it disrupts the flow. And so that's what those words mean. I moved in then into the book through the pages that dealt with the red and green tag system. This came about because they had a prioritized list of things that had to be done, one after the other. And when the guys out on the machines were working, and they did this one, and then they did this one, and then they went to go to this priority job, and the material was not there to do it, they just stopped working. They didn't know any better, so they just waited until those parts showed up because they thought that's what the priority of them was. So they didn't just keep working on whatever was going below. This caused Rogo, the plant manager, to get very angry, but his anger was misplaced because the workers were doing exactly what they were told to do. So the production manager says, well, I guess we need a system. And right on the fly, right now, Rogo makes a management decision and says, I'm going to have these jobs listed in the priority order, but I'm also going to add red and green tags, to red tags for the hot parts or the bottleneck parts, and then a number on those tags. The lower the number, the more priority it is for late overdue orders. And then green tags go on the non-bottleneck parts that I described over there. If you see red tag parts come up, stop what you're doing. Unless you can work for another half hour on the green tag parts, then stop that and get right onto the red parts. If you're in the middle of a setup for green parts and red parts come up, break that setup, put on the red parts fixture plate, indicate it in, get the clamps, get going, because those parts are the ones that control the throughput of our plant. So that's why they came about. They came about because non-bottleneck resources were being overworked, and then because they were working on non-bottleneck parts and they weren't even the bottleneck resource, they starved the flow of parts to the NCX10, which is the bottleneck. That ought to be fairly clear now. So then last I talked about offloading. But before I got there, I came to this. And this is our hourglass, metaphor, analogy, whatever you want to call it. Sand is up in the top here, and it cannot flow through the bottleneck any faster than this bottleneck is going to let it. So we have only two choices here. We can widen this bottleneck, but we'll break the hourglass maybe. So we only can make very small improvements here, but that's exploiting the bottleneck. We relieve the bottleneck and more sand flows through, and we get more production out of the NCX10, for instance, by taking away the brakes, the brake times, staggering the brake times so that our people still get their by law brakes, but there's no time during the day when the bottleneck resource isn't running. We can also go with these red, green, and gold tags to enable the flow through there. Also, making sure the machine stays running all the time is a way of relieving and exploiting the bottleneck by making sure nothing can get in the way of that sand flowing through there. Now, offloading is a different concept where the sand is no longer going through the bottleneck. It's taken off, it's taken care of somewhere else, and our parts come back through down here in the bottom for assembly. All right, so that's what offloading does. So what do? They take some of their parts and they have them heat treated at a vendor across town. Then to offload the NCX10, they go back to the old days and they get the old machines, 3 of the old machines. They hire some more machinists and they take the parts that used to be done that way and they do them that way again, and they offload parts that had to go through the NCX10. I left us at about page 204, where Stacy begins to panic about the bottleneck spreading. They start to get a little bit of improvement, and then it seems like everything's a bottleneck. Just like when Stu was talking to the class the other day, and every job that came into the shop he was working in had to be a hot job. So they get a grip on that, and I think it's very interesting, and that's what we'll talk about next Tuesday when we put this milestone past us. Thank you, and we'll see you next week.